Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to find the indefinite integral. And this is where we're going to see a lot of playing around with all these different trig expressions and specifically raised to powers. Okay? And I'll focus on that first, because what I have to decide is what strategy I might use here. And my strategy very much is going to be influenced by the fact that I see sine being raised to an odd power. That's key. What I'll do right now should work anytime we have sine times cosine raised to different powers, and sine is being raised to an odd power. What I do is I'm going to rewrite this right off the bat and break one of those factors of sine off and pair it up with the dx. Let's get started there by rewriting the original integral, but with one of the factors of sine just written off to the end here. So sine of x dx. I'll even put parentheses there to draw your attention to that. Because we do that stripping off of one factor of sine, for two reasons. One is because if you had odd power of sine and you took one off, you now have an even power of sine, right? And so we're going to rewrite this using the Pythagorean identity. I only have two powers left over, but you could have 2, 4, 6, 8, anything, but it'll be even. And so I'll be able to rewrite using the Pythagorean identity, so it'll end up being in terms of cosine. And so the second reason we do this, if you just listened to what I said on the first reason, everything will be in terms of cosine. So we're going to let u equal cosine, and so my du is going to be minus sine dx, and that's what's going to get replaced right there in my original expression. Okay? All right, so my next step here is going to be to rewrite that sine squared as something involving cosine using that Pythagorean identity. Right? So equals integral still, and then 1 minus cosine squared of x. Replaces sine squared of x. I still have that cosine squared of x. And I still have that sine of x dx, which I'm anticipating disappearing when I do my u substitution here, which I think I'm ready to do now. So let me step over here and do the u substitution of u equals cosine of x. So du equals minus sine of x dx. There's where you have your match there of the sine x dx. We're only off by that factor of a minus 1, so we'll just throw that all the way out in front. Let's come back over to the main integral. This equals minus the integral, parentheses 1 minus u squared, times this cosine also getting replaced with a u squared though. Sine x dx is what's becoming a du. Don't forget that minus sign. I did pull mine all the way out in front. And now we have a very simple integral. I think I'll distribute first, and we'll end up just with a power rule, a couple power rules. I'm going to distribute and get a u squared minus u to the fourth. If you don't mind, I'm going to push the minus sign back in, actually. I think I'd like this u to the fourth to be positive. A little bit of algebra. And so then this u squared will end up being minus when I distribute that. You absolutely did not have to do that algebra. If you kept your minus sign out in front, we'd have the exact same answer at the end, right? Now I'll do my power rules, where this equals u to the fifth over 5 minus u to the third over 3 plus c for good measure. And I'll slide over for my last step here, because most of the time what you'll do with u substitution is substitute back in, right? So 1/5. U now is cosine. This u was to the 5th power, so cosine to the 5th power x minus 1/3 cosine to the 3rd power of x plus c. And you've got it. That'd be my final answer here, okay? So again, with this problem, what was key for me is I recognized that sine was to an odd power. This thought process should serve you pretty well anytime you're seeing that. Sine times cosine, and sine is to an odd power. Okay? Hope that helps.